is it possible for a Hilbert hotel to run out of rooms? Yes. What is this Hilbert hotel thing? This Hilbert hotel paradox is a paradox about an infinite hotel with an infinite number of rooms. This paradox was made up by German mathematician David Hilbert. So how it works? We have this hotel with infinite rooms, right? And now let's say it is full, so there's an infinite number of guests in this hotel. Right now, a guest shows up and he needs a room, so only one person shows up. This manager is very clever, so what he does is that he moves person in room n to room n plus 1. So if you're in room 1, you move to room 2. If you're in room 2, you move to room 3. If you're in room 3, you move to room 4. If you're in room 4, you move to room 5. If you're in room 71, you move to room 72, and so on. In this way, there will be one room left for the new guest, so he can stay in that one room, room number 1. Alright, what if a bus shows up, and this bus is no ordinary bus? This bus is carrying infinity people, and they all alight from the bus, and all of them need to stay in this hotel. Once again, this manager is really clever. What he does is that he moves person staying in room n to room 2n. So if you're staying in room 1, you move to room 2. If you're in room 2, you move to room 4. If you're in room 3, you move to room 6. And at this point of time, when everybody moves, the odd number rooms in the hotel, all of the odd number rooms, will be left vacant. So this means that the even number hotel rooms will be occupied. Now, you know that there's an infinite number of odd numbers. So with this infinite number of odd number rooms, all the infinite people in the bus will be able to stay in all the odd number rooms in the hotel. What if an infinite number of buses, each carrying an infinite number of people, appear in front of the hotel? And each of these infinite times infinite number of people needs to occupy a room in this hotel. What should the manager do? Well, it's very simple. So this is what we do. We take an infinite spreadsheet with infinite rows and infinite columns. And over there at the first row, we have the hotel room number. Hotel room number 1, hotel room number 2, hotel room number 3, hotel room number 4, and so on. And now we have on the most left-hand side column, we have bus number 1, bus number 2, bus number 3, and so on. And on the second column, we have B1S1. And what this means, it is bus 1, seat number 1. And next to it is bus 1, seat number 2, bus 1, seat number 3, bus 1, seat number 4. And below there, we have bus 2, and we have bus 2, seat number 1, bus 2, seat number 2, and so on. And we will have to draw a zigzag line across this table. So this zigzag line just stretches like this. So HR1, HR2, B1S1, B2S1, B1S2, HR3, HR4, and so on. And from there, it's pretty simple. Just match up each person to a unique room number. And we just sorted this infinite number of buses, each with an infinite number of people. Right now, another bus pulled up in front of the hotel. This time, this bus is different because, well, it has infinite number of passengers again, but this time each of them has a unique name. And it consists of 2 letters. And let's just use 2 simple letters, A and B. So one person may be named AABB, AABB, or another person may be named BBAA, ABBA, BA, and so on. So each of their names go on infinitely, so they have an infinite letter name. However, when one of them walked up to the manager and said, "Can we have a room?" the manager said, "No, unfortunately, we are unable to accommodate all of you." This is not because it is filled. Even if the hotel is empty, even if the hotel is empty with nobody in it, no one is staying in it, the manager will still be unable to fit in all these people. Now this comes to countable and uncountable infinity. Yes, I'm trying to say that there are different kinds of infinity. So infinity is not what you think. Infinity is not just numbers that go on forever and ever and ever. In fact, there are different kinds of infinity. And the examples, like when one person showed up, that's not infinity. When an infinite number of people showed up, that's countable infinity. When an infinite bus showed up, that's infinity, countable infinity. Alright, so when an infinite number of buses with infinite number of people each in it, that's countable infinity, right? This time, this special bus with people named ABAB is uncountable infinity. Here's why. Over here, we have the name list of everybody in the bus. So you can see here that number 1 is AAB, AAB, AAB. Number 2 is ABB, ABB, ABB. Number 3 is BABA, BABA, and so on. Number 4 is BBA, 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 and so on. Number 5 is BAB, 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 and so on. While for 6, it is AAA, AB, AAAAB, AAAAB, and so on. While for 7, it is ABBB, 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 and so on. Right now, I am going to do something. Alright? This is what I'm going to do. For the first name, I am going to take the first letter and I am going to change it. So the first letter of the first name is A. So I shall change it to B. Alright, for the second name, I will take its second letter and change it. So in the second name, the second letter is B. So I'll change it to A. Now, for name number 3, I'll change its third letter. So its third letter is B. I'll change it to A. Alright, so I shall continue like this. As for the fourth name, I'll change the fourth letter and I'll get A. And for the fifth name, I'll get the fifth letter, which is A, so I'll get B. For the sixth name, I'll get B. Right. For the seventh name, on the seventh letter, it is B, so I'll change it to A. Alright. Over here, I have created a new name, so it goes on forever. So I will take the 8th letter of the 8th name and change it. I'll take the 9th letter of the 9th name and change it, and so on. I've created an entirely different name that you would never find on this list of the infinite number of people. Why? Because it is different from the first number. Because of the first letter, it's different. It's different from the second number, from the second name, because of the second letter. Different from the third name because of the third letter. So you can see here that despite all this listing, I can create an entirely new name that is not found on the list. So you can see here why this manager did not allow these people on the bus to enter. This is because there will be an entirely new name, and this is uncountable infinity. Alright, now I'm going to work with numbers to demonstrate infinity instead of letters. Over here you have a Numberphile video with James Grime listing infinity. First he lists 1 over 1, 1 over 2, 1 over 3, 1 over 4, all the way until 1 over 7. And then he lists 2 over 1, 2 over 2, 2 over 3, 2 over 4, and so on. Alright, so here he's listing them. And then he lists 3 over 1, 3 over 2, 3 over 3, 3 over 4, and so on. So each numerator in each row is the same. Alright, now he explains that he prefers calling uncountable, unlistable, and countable listable because you cannot count infinity, but you definitely can list them like what he's doing now. And he's gonna list them not row by row or column by column. Instead, he is going to list them diagonally, which is similar to what I did with the infinite number of buses, each with an infinite number of people. Alright, so he's going to strike out the numbers diagonally, and here he's doing it You have seen countable infinity, or rather listable infinity. How about uncountable, or rather unlistable infinity? We can do it in the same way as our ABAB bus. So we can have numbers like 0.141592 and so on, or we can have numbers like 0.123456, and we can do it in the same way we did for the people in ABAB bus. Let's start listing uncountable infinity. Over here we have our 7 decimal numbers, and we are going to do the same thing we did for the letters. So 0. Over here we see the number 1, all right, 0.1415, so we take the first number and we add 1. Now for the second number, we see that is 0.123456 and so on. We'll take its second digit and we add 1, so it will be 3. Now for the third number, we'll take its third digit and add 1, which is 9. Now for the fourth number, we have 0.638459 and so on, and we'll take its fourth digit into the decimal place, which is 4, and we'll add 1, 5. Alright, now as for the fifth number, we will take its fifth digit and we add 1, so we get 3. And as for the sixth number, we will get its sixth digit, which is 3 once again, and we'll get 4. Alright, now for the last number, we'll get its seventh digit, which is 2, and we'll get 3. Alright, and in case if you're wondering, what if we get a 9 in one of its digits? We'll just get it back to 8. Alright, it doesn't really matter as long as we can show uncountable infinity. Over here, we have created an entirely new number that is not found in this list. Even if we were to list out all the decimal in existence, all right, we will not find this number. This number in the list that we made. So we just made an entirely new number, just like how we did it for the ABAB bus. Surprising, isn't it? So this is how we demonstrate uncountable or unlistable infinity.